Hey, Joe, what's up?
Hey, Maria. I was just here working on our Summer of HPC project.
Oh, nice. Since the summer is coming to an end, I think that we should share with our peers the fascinating things that we have discovered about the cloud research field.
Yeah, sounds great. Let's do it.
Hello, everybody. Well, these last months, we've been working on the project 2127, which is maximizing data processing efficiency in the cloud with a twist for research data management from the SURF organization as part of the Summer of HPC 2021 program.
The service that we use is Serve Research Cloud, which is a collaborative portal for research, which is used for building virtual research workspaces. A workspace is a research environment where a user can select an application along with the data that want to work on, then deploy a virtual lab in the cloud for the user and their colleagues to work in. Furthermore, we can create reproducible research environments, use the best resources for the research, and work together securely. So, using the cloud systems to conduct scientific research when working with large amounts of data seems to be useful, since it provides an easy way to adapt our system resources to our needs, and therefore serving as a cost-saving and sustainable approach. But data handling can be a very demanding task, given that it's dependent not only on the system resources, but also on the type and size of data that is being dealt with. Here is when cloud storage comes handy, because it allows us to store all the large information that we want to work with without compromising any disk storage. So in conclusion, when working in the cloud, selecting the appropriate storage system is key to the performance.
Now, to test how different storage types affect performance, SURF provided us with some storage systems which are represented here. The first one being Research Drive, which is a cloud-based shared environment designed for requirements like large storage quotas and collaborative work. Then Dcache, a distributed storage for scientific data, proven to be capable of managing the storage and exchange of several hundreds of terabytes of data. And finally, we have iRoads, that stands for the Integrated Rule-Oriented Data System, an open source data management software used by many organizations worldwide. Now, in testing the effective handling data in different storage systems, we need assessment on the matter, and it is part of our goal to catalog the best practices for real case problems. And in other words, a collection of reference implementations of pipelines for real life cases using different data services.
Let's look at the steps followed. First, we need to know the data type. In this project, we've been working with climate data from the ERA 5 dataset, provided by the European Center for Medium Range Weather Forecast. ERA 5 provides hourly estimates of many atmospheric, land, and oceanic climate variables from 1979 to present. The data can be downloaded directly from the Climate Data Store website or through API requests as netcdf files.
Now, introducing a bit about our sample problem, by working with this climate data, it is and was necessary for us to always select a given working region, time span, and climate variables that we want to work with. Then creating an algorithm that is responsible for accessing the data stored in all of those different storage services and process them in a way that accomplishes the use case scenario that we want to study. Now, going through the algorithms that one can apply to the data, we have encountered and applied these additions that allows to achieve better efficiency in the data processing. The first one being online algorithms that can process its input in the order that is fed to the algorithm without having the entire input available from the start. And the other addition that we considered was parallelization, where we resorted to multiprocessing packages that support spawning processes using an API similar to the threading module. This allowed us to work with several data files simultaneously, since a large data set can be split into multiple files. Now here, we represent some of the visuals of the data and one example where the average calculation per spatial grid cell of the total precipitation is being calculated for data corresponding to 1 day, which is represented in the left image, versus the hourly total precipitation of that day in the right image.
Having proved that the algorithms work well, now we need to benchmark the storage services. Benchmarking is the process of determining the best processes, strategies, and techniques for achieving our business goals. In our case, is to choose or combine the best compute and storage infrastructures for the research. For that, we test the storage system by running several times the same algorithms over the same data stored in the different storage services explained before. Then we calculate the mean and standard deviation of the running times. The end product of this analysis is that the algorithms work faster when the data is stored locally than in Research Drive. And for those who don't trust only words, here are some preliminary results. By a quick analysis of the graphs, we can see that local storage is where the job is done most quickly. However, there will be a moment that the files will not fit in the local memory system. For example, if we consider a bigger region, such as the entire world.
For the final considerations, we have that working with climate data is of great importance, allowing people to trace models and make provisions about the future, but this can be a very demanding and resourceful task. And by working with this kind of data and exploring which storage type allows to maximize efficiency and speed of data processing, we are contributing to make this task less laborious and less expensive.
Finally, we would like to mention our future plans, which are tackling new datasets such as the ones from the compact muon solenoid experiment found in the CMS open data from CERN, and addressing other storage services, for instance, the cache or iRoots, because every dataset is different, and for data processing in scientific research, it's important to use the appropriate storage.
Finally, we thank you for your attention.